Welcome to ClickMyProject.com. Our project title is the Cellular Network Traffic Prediction based on the Correlation Convolutional LSTM Self-Attention Network. This is an abstract. To enable the 5G internet system and automated network management, it is essential to predict the feature dynamicity of the network traffic. We suggest a correlation-based convolutional LSTM self-attention-based network in this model to reliably anticipate complicated cellular network traffic. The correlation layer in convolutional LSTM is used in the proposed CCSANet to enhance the ability to extract the sequential spatial data. Additionally, the self-attention is used to aggregate the ability to derive the relationship between the feature of the network traffic and the feature of the external element. In this process, CCSANet is designed for the network traffic in mobile phone activity, collect the data for the 7 days and store them as a CSV file for the processing. In the dataset has the features such as SMSIN, SMSOUT and CALLIN, CALLOUT internet usage. In our design network has the 4 modules: correlation convolutional LSTM, self-attention module, time embedding and fusion output module. Using these 4 modules, design a network for calculating the network traffic level, which day has the maximum amount of network in a week, also calculated by comparing the total activity. Then build the model using the 4 modules and fit the model in our training dataset, and prediction is done for the test data. Finally, calculate the accuracy versus loss graph for the model design. This is an objective. To design a CCSANet with 4 modules, to implement the time embedding module, to enhance the performance analysis. This is a full flow diagram. From the cybersecurity dataset, we want to import the data and pre-process it by the handling missing values and the label encoding, and they extract the features from the dataset. And after extracting the features, we want to classify it by using the models such as time embedding model is mainly used for the classifying the weekdays as well as the weekend, and CCSANet is a LSTM model. LSTM model is used for predicting the feature of the weekday as well as the weekends, and 2-layer convoluted network is for increasing the performance. Finally, combining these 3 modules, we have the CCSANet. After resizing the input of features, and then move on to the compiling the models. After model compiling, we want to fit the model for the training dataset, and then predict the model for the testing, and finally we have to calculate the performance of this model. We have to calculate the RMSE and the MSE and the R2 score, because it is a network traffic intrusion in the internet usage. So we want to calculate the mean square error and then root mean square error. And this is a system architecture. First one is the blockchain dataset. From the blockchain dataset, we want to pre-process the data and then split the data and extract the features, and classification apply for the feature separation. Here we use the CCSANet, and then prediction is done for the testing data. Finally, calculate the performance analysis such as RMSE and then MSE and then R2 score for the model. And this is a one more flow diagram. First one is the data set, and then next is this data selection and pre-processing done by the label encoding, and remove the null values, and split the data as the training as well as the testing as the ratio 8:2, and extract the feature, and classification is done for the classifying the features by using the CCSANet, and then prediction, performance analysis. use case diagram. From the user point, we want to first select the data, pre-process it and split it, and feature extraction, classification, performance analysis. And this is an ER diagram. From the starting point, we want to load the data and select the particular data, pre-process it and split it and extract the feature. Classification is done by the CCSANet, and then performance analysis. Finally, we calculate the root mean square error. Sequence diagram. From the start point, pre-processing and the classification, performance analysis. 4 sequences are done in the process. When we start our program, then we move on to the select data and load data. Pre-processing is done by the label encoding and fitting the null values, and then split the data as training as and the testing, and classification is fit by the CCSANet. Finally, performance analysis. After executing our process, our first stage is our epoch is running. There are 10 epoches. We have to train this data set. So first, from this epoches, second one, third one, and final the 10th one, we have to calculate the accuracy as 76%. In our proposed, it didn't mention about any accuracies. In this, we have calculated 76% of accuracy. This is a train accuracy versus epoches and loss, and training loss is epoches versus the loss. And finally, we calculate the parameter calculations such as mean absolute error and then MSC error and then root mean square or 2 value.